Hello guys, we are at the next video of the section, Pre-Processing Data. In the previous video, we learnt about classification. In this video, we are going to remove mean, scale the dataset, and normalize it. We deal with a lot of raw data in the real world. Machine learning algorithms expect data to be formatted in a certain way before they start the training process. In order to prepare the data for ingestion by machine learning algorithms, we have to pre-process it and convert it into the right format. Let's see how to do it. Create a new Python file and import these packages. Define some sample data. We will be talking about several different pre-processing techniques. Let's start with binarization. This process is used when we want to convert our numerical values into Boolean values. Let's use an inbuilt method to binarize input data using 2.1 as the threshold value. Add these lines indicating that. Run the code. You will see these values. As we can all see here, all the values above 2.1 become 1. The remaining values become 0. Let's look at mean removal. Removing the mean is a common pre-processing technique used in machine learning. It's usually useful to remove the mean from our feature vector so that each feature is centered on 0. We do this in order to remove bias from the features in our feature vector. Add these lines to the same Python file as in the previous section. These lines display the mean and standard deviation of the input data. Let's remove the mean using this code. If you run the code, you will see these details printed on your terminal. As seen from the values obtained, the mean value is very close to 0 and standard deviation is 1. We will now look at scaling. In our feature vector, the value of each feature can vary between many random values. So it becomes important to scale those features so that it is a level playing field for the machine learning algorithm to train on. We don't want any feature to be artificially large or small just because of the nature of the measurements. Add this snippet to the same Python file. If you run the code, you will see this printed on your terminal. Each row is scaled so that the maximum value is 1 and all the other values are relative to this value. Our next topic is normalization. We use the process of normalization to modify the values in the feature vector so that we can measure them on a common scale. In machine learning, we use many different forms of normalization. Some of the most common forms of normalization aim to modify the values so that they sum up to 1. L1 normalization, which refers to least absolute deviations, works by making sure that the sum of absolute values is 1 in each row. L2 normalization, which refers to least squares, works by making sure that the sum of squares is 1. In general, L1 normalization technique is considered more robust than L2 normalization technique. L1 normalization technique is robust because it is resistant to outliers in the data. A lot of times, data tends to contain outliers and we cannot do anything about it. We want to use techniques that can safely and effectively ignore them during the calculations. If we are solving a problem where outliers are important, then maybe L2 normalization becomes a better choice. Add these lines to the same Python file. If you run the code, you will see the normalized data printed here. Cool! We pre-processed the data in this video. In the next video, we will learn about label encoding.